Hello everyone, welcome to Gamma's Academy, and we are in the tutorial of data science courses from very basics, and we are in the series of statistics courses. So today we are going to learn another topic of statistics which is very important, and that is normal distribution. So we discussed about the probability distribution. So if we draw a probability distribution and if my curve looks like this, that is known as normal distribution. In this case, if this is my mean, if this is my mean, so these are my standard deviation terms. It means from mean, this value is 1 sigma away, this is 2 sigma, sigma is the standard deviation, then 3 sigma away, and so on. Similarly, like this is minus 1 sigma, minus 2 sigma, and minus 3 sigma. So this is my normal distribution curve. Normal distribution curve is also known as bell-shaped curve because it looks like a bell. It is also known as Gaussian distribution. And the function to draw this normal distribution is something like fx is equal to 1 upon under root 2 pi sigma square e to the power minus x minus mu to the power 2 divided by 2 sigma square, where sigma square is variance, mu is the mean, and sigma is the standard deviation. So to draw the normal distribution, we need two things: the average measurement, that is mean, and we need the standard deviation, that is sigma. So the mean will tell where my central value of the distribution is, and sigma will tell, or the standard deviation will tell, the width of this curve. That's how we can plot normal distribution. So the interesting fact of the normal distribution is that in most of the cases, if you draw the probability density for the given data set, you will find that follows the normal distribution. If let's say if you talk about the height of average person, so most of the height will lie in this range, and very rarely the person will be very small and person will be very tall. So if you talk about high or any most of the natural phenomena, the curve you plot will be in form of normal distribution or will close to normal distribution. Okay. How do you test if your data is following the normal distribution or not? So there are around 3 or 4 methods we can apply and check if my data is normally distributed or not. So we have KS test, we have Shapiro-Wilk test, we have to test skewness, and we have to test the kurtosis. We will talk about all these theorems and the terms in coming videos. No need to worry about these things, but we should understand what is normal distribution in this video. So let's move on. So there is one empirical rule which is applicable to the normal distribution, and it says, see here I have drawn a normal distribution where this middle point is my mean, then it is mean plus 1 sigma, mean plus 2 sigma point, mean plus 3 sigma, similarly towards left mean minus 1 sigma, mean minus 2 sigma, mean minus 3 sigma. So this theorem says, and this theorem has been arrived after doing several tests on the data. So it says like 60 about 68% of data will always lie within the one standard deviation, means within this range. So in this range, almost 68% data will always lie. About 95 point some 95.3% data will lie within two standard deviation. Means let me take another color. Let's take the green. So my 95.3% of data will always lie in this range, and around 99.7% data will lie in this range. So this is how the empirical rule is defined. If you have heard, if you have done any statistical experiment or any theorem you have applied, you may have heard about 1.96 value of z. It means 1.96 sigma, which is very close to 2 sigma, means over somewhere here my 95% of data will align, where this position is 1.96 sigma this side and 1.96 sigma this side. So that means my 95% of data will lie in the range of plus minus 1.96 sigma. You can calculate that, and this is very important in any statistical experiment, because we say we are 95% confident, or we are 95% confident that my value will lie between this range. Let's try to understand the concept of this theorem by doing one example. Let's say I have a question where IQ scores have a bell-shaped distribution with a mean of 100. So the mean means mu is given as 100 and a standard deviation of 15. So sigma is given 15. So I want to know what percentage of IQ scores are between 70 to 130. So if you see my mu over here is 100, my sigma is 15, so means this side it is 115, adding 15 to 100, adding 15 to this point, 2 sigma, so will be 130 this side and 145 here. Similarly, we will move to the left, so 100 minus 15 will be 85 this side, 85 minus 15 will be 70 this side, and 70 minus 15 will be 55 over here. So I am interested to see what is the percentage of my population will lie in the range of 70 to 130. 70 to 130, that is the range of my 2 sigma, and I know around 95.3% of data will lie in 2 sigma distribution. So I can say around 95% of IQ scores would lie between 70 to 130 IQ score. Okay, so that's how we can apply the empirical rule. We can interpret it, and we are going to use this normal distribution very frequently, because most of our natural phenomena will follow or closely follow the normal distribution curve. So I hope you understood this, and we'll see in the next video. Till then, enjoy learning and have a nice day.